What is up, everyone? Sorry I'm a few minutes late. As you may know, I am still recovering from COVID, although starting to get better pretty quickly, so that's good. No one in my family caught it super heavy. But in any case, I figured I'm still, for any reason, in the mood to live stream. Maybe that'll raise my mental spirits and give me some motivation to chat with some random combo lords and as usual, get carried away on a few rants of stories from my life or little mathematical tidbits that may not make in videos. What is up, Magic Fellow? How's it going? For those who haven't seen yet, after this stream, you can peek on this bonus channel I just put out today also. The first video of a certain type on this channel, which is a sort of longer, full length thing that could be seen as like taking a class period with me almost. It's 26 minutes of me talking about cool patterns in grid shapes. And I might make that into a full episode someday, but I wasn't able to meet up with any cameramen right now while I was sick. And so I was like, why not film myself just a little like hang out with me, one take, little lesson about some stuff that was on my mind. Sometimes I have some thoughts like that on my mind that'll probably end up in an even more elaborate way in a full length episode with cool visual demonstrations and stuff. But while they're fresh on my mind, sometimes like to just get them out there. And here we got my cat Sage. Hi, visitor. Hi, Sage. Want to say hi to them, Sagey? He likes helping out in the combo classroom. All the cats are so wonderful. And the stray cat, Sassafras, is getting very used to the house. He was fully stray not long ago. Sorry if I'm leaning over, I gotta pet my Sage. Um, but his twin look-alike, who we adopted from the neighborhood, ended up really liking getting pet and hanging out inside. And although he gets scared inside, I've been trapping him in to hang out, making him get used to the indoor world a little bit. And he's very well behaved and very chill. That one's Sage, and the stray is Sassafras. And some of you may have also seen the Fluffosaur Dandelion. Someone's wondering how to pass freshman math. Now, that's probably just going to require a decent amount of focus. Now, for me, math was something that came easier because I spent some free time on it also. So I was usually ahead of the class already based on my own personal hobby of it. So I didn't have as much difficulty needing to train my focus for that. But I would almost compare people who don't like math learning that to how I felt learning like some more memorization type classes about certain types of history or science that required a lot of memorization. And with those, it really just takes a lot of note taking, referring to your notes again, kind of thinking thoughts actually through as opposed to letting them skim off the surface of your brain. Sometimes stockpiling a little temporary memorized thing with mnemonic devices or memory techniques. And other times, hopefully, having some fundamental intuition for a concept that in a good class or with a good teacher, having a good problem solving ability and a good intuition paired with just a few key facts can get you pretty far. Um, Someone's wondering on my thoughts on 7 and 11. Funny that you are asking about those, even though that person may have already left, because I have made a video that was pretty popular on here and TikTok where I roasted the numbers 7 and 11. It's funny that the videos that blew up the most on this channel are often the same videos that blew up the most on TikTok. And there were videos that, even though I did like them, I like a lot of my videos, and I didn't have any reason to think those would be the ones to blow up. But there must be some catchy factor about them that made them do well on both sites. And one of those was me kind of ranting with a syllable chart of how many syllables each letter has. And I think it worked well because it came across as a little comedic for those who weren't into math of like, why am I so obsessed with the syllable discrepancy that I've made a whole chart about it? But I want to make even more charts about the syllable discrepancy because 7 and 11, first of all, the way they're pronounced, which was in that short video, is absurd. They have the wrong amount of syllables. You can refer to my video for that. But the reason I brought up the video real quick that was funny is the official 7-Eleven Twitter account replied to that and was, I mean, TikTok account replied to my TikTok and was like, what'd they say? They said, I have a video of it, and it's on the TikTok, but they said something like, "This is a personal attack." So I figured out ways for me to come up with a possible truce with 7-Eleven that involves if they change their name to something with better syllable structure. I have a lot of suggestions for things that could work instead of 7-Eleven and imply those two numbers. For example, if we called it 9 plus or minus 2, 7 and 11. We could also call it fourth and fifth prime number. Other options like that. Now, asking about the numbers 7, 11 in particular. Now, the numbers 7 and 11 are cool because they're prime numbers, but they're not the most relevant prime numbers. Like 2, 3, and 5 have a lot more powers than 7 and 11. Really, 2 and 3 have so many powers. Five's a little behind, seven's a little behind, 11's a little behind. So by the time you get to 11, a lot of its cool powers come from in our base 10 system. It does cool stuff because it's one higher than 10. So if we're counting in base 10, 11 does a lot of cool stuff, but that's more stuff I like about the number that's higher than whatever base you count in. 7 also just doesn't have that many good traits, even in our base 10 system. The fractions are sloppier. It's seven's the only number that doesn't have any factors in common with 10. Like 2 and 5 are in 10. 4 and 6 and 8 have a factor of 2 that's in 10. I mean, factor is bigger than 1. And 1, has it. You kind of could count 1 in a way because 10 has a 1 in it. But the other one, 7, is the only one that the only factor of it that's in 10 is that 1. Um, and so 7 has some traits that are undesirable, even in our base 10 society. And it's not the best number. A lot of people choose it as a lucky number. I advocate for 6 being the new lucky number. 6 is a lot cooler than 7. 6 has a lot of good properties. Um, so yeah, as somebody noted in the comments, they were like, "Trust, man, he'll check the chat soon," which is true. My fans will know that I don't always reference the chat, but I usually comb through it and answer a bunch of the questions over the course of the stream. So someone's recommending A Mind for Numbers. Cool. I'm glad for any book recommendation. I haven't read that. Maybe I'll check it out too. Even if I already know a lot of the concepts in a book, it can be cool to see different approaches on it. I'll do more recommendation videos at points in the future too of books I've really enjoyed, but I've already talked about that a little bit in streams of a few starter recommendations of books. But there are plenty of awesome books that I think I have learned a lot more from than any given class I've taken. Um, Now, someone's wondering about tips for mental math. Now, I would say it's good to learn, if you mean mental math as far as like being able to do the typical functions of adding, subtracting, dividing, and multiplying numbers in your head, because there's different types of mental math. But if you mean like arithmetic, then I would say it's good to learn tricks about what certain digits do, like when you're multiplying multi-digit numbers, that the last digit is what affects the last digit, and each other digit have certain places that they could or couldn't affect in the multiplying. And it's also good to remember things like if you're multiplying or dividing two large things, you can sometimes split them. Like if I wanted to know 101 times something, I would do 100 times it and then add one copy of itself also. So, sometimes splitting one of them into a really easy number and another shred that's close to the number can make it easy to do tricks like that. But really, it's also kind of a memorization thing that I've never committed too much time to. So I'm not like a speedy guy at doing calculations like that always. There's a few tricks I've learned for fun related to that. And there's certain things that are just stuck in my head. Like I know the list of prime numbers surprisingly well and things like that, of like 2-digit primes and stuff. But I don't know, like, it would take me a minute to multiply or divide stuff quickly. But there are patterns. You can also look at patterns in like modular arithmetic and stuff and learn rules. Like if I want to know about cube numbers, well, every cube number turns out to be one away at most of a multiple of 9. That relates to the digital root of numbers in our base, meaning when you take their digital sum, the sum of the digits enough times down to one digit. So cubes will have a digital root of 1, 8, or 9. So sometimes you can, like, if I'm trying to cube a number, qubit approximately if I'm close enough to know the nearest thing that it has a digital root of 1, 8, or 9. And someone's learning about long division. That's kind of similar. You'd have to learn a lot of little tools and be good at problem solving when the tools are right to use. Um, if you had to divide something really big, I would probably reverse engineer it. Like if you said like I have a million divided by 6, I would be like, okay, that sounds 3-ish, but well, I mean, one way to do that would be to do like a million divided by 3 and then try and half that in your head. But you could also be like, what's a number about that times 6 is about a million? And then you get in the ballpark, and that can help you. Um, so backtracking can help too. You can always try and flip operations. But here's a quick one since percentages come up so often. I made a quick video about this, but it's worth writing down because it's something that I'm surprised more people aren't aware of. To some, it might be really obvious, but to others, it might be a helpful little trick. Do I have a pen around here? Gotta have a pen somewhere. I just found stuff out here. Let's see. Is this the pen I was using? No, that's a dead pen. I have dead pens all over here. There's got to be a living pen. Here we go. So, here's a good trick with percentages. What does percentage mean, first of all? A percent of B. What does this mean? This means percent means A hundredths. Of means times, basically. Typically, when you see of, you know it's probably going to be either multiplication or division, and often multiplication. This one's saying what percent of B. So since this is going to be a fractional quantity, typically, if I'm saying like 50%, 50 over 100 is fractional, we're multiplying it by B to see that amount less than B. So we have A over 100 times B is what it's saying. But really what that's saying is A times B over 100. So it's really saying A times B. In our system, too, it's saying A times B, and then you move a decimal over. We got to hop a decimal over twice to make it hundredths. What that means is if you can multiply these two together easily, you just multiply them and divide by 100, moving the decimal. And even if you can't multiply them both, it sometimes gives you a really useful hack. If A% of B is AB over 100, so is B% of A. So they're the same. A% of B is B% of A, always. So if you need to know, like, what is 7% of 25, it's a lot easier to find 25% of 7. And they're the same answer. And it might be easiest to say 7 times 25 over 100. So those are percentage hacks. Percentages, it's a weird thing that it's so common. Really, it means multiply the two together, divide by 100, but you structure the order of which one you're asking about based on the second one being presumably a fixed quantity and the first being some thing related to that. So it's a weird thing that it's so common to be hundredths because our society loves hundredths. Our society's obsessed with, the square of the base, of course. Most base-related societies would. Unfortunately, our base is 10, so that squares 100. Now, if you do want to see a fun fact, you can see how 100 does relate to some grid counting. So there are some grids related to rectangles and squares and triangles that do relate to the number 100 in the new video I dropped on this channel. You can watch after the stream if you haven't yet. But that is really a trait that comes around because of it being 10 squared. And and the only reason 10's cool, which I do mention in that video, but I'll reiterate here. The only reason 10's cool, not the only reason. Being 2 times 5 is kind of cool. 2 and 5 are low prime. So that makes 10 more probable to show up in nature or something than something like 14, 2 times 7. However, 2 times 5 is not the coolest thing about 10. Being 1 plus 2 plus 3 plus 4 is the coolest thing about 10. Now, that doesn't mean 10 is cooler than 6, because 6 is 2 times 3, the smaller primes. 6 is a 1 plus 2 plus 3 without needing to drag the 4 in the mix. And it's also 1 times 2 times 3, which can't do that timesiness with the 10. So this does not mean in any way that 10 has a trait 6 doesn't have. 6 is still better. But I will give 10 credit for being a triangular number. And for those who don't know, triangular numbers are one of my favorite types of numbers, which are known as that because you could draw them as dots of triangles, or wait, grids of dots in a triangle shape. And that's 10 dots. So that is why 10 is cool, not this. However, this is how our society makes 10 cool, 2 times 5. Not cool, but how we've made it fundamental in an annoying way. Not fundamental in terms of like nature, but fundamental in terms of surviving in today's society. You find tens stealing a lot of things from highly composite numbers. Now, there's, as some of you have seen in my videos, much more practical versions of 10 and a million and a billion. And in fact, and someone said my favorite kind, I didn't say favorite. I think I said one of my favorite. And if not, I'll make sure to add that because I have a lot of favorite kinds of numbers. I can't say triangular numbers are my favorite. However, I'm going to say that due to the fact that the simplest of all sequences of numbers you can imagine is the natural numbers, whether or not you start with 0 or not, that sequence starting with 0 or not going upward is like the simplest sequence you can imagine. And if I take going through this, multiplying all the stuff that's happened so far as a new sequence, 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4, these are factorials. And those are just as cool as triangular numbers. They're incredibly important and fundamental. But the triangulars are very similar. A lot of people don't realize that the triangular numbers and factorials are like cousins because they're taking the natural numbers and doing an iterated process through them of just this one multiplying, triangulars adding. And so triangulars, we'll see, after the third term will never be ahead again. Factorials will be in the lead. But 6, they tie out. And triangulars are winning in terms of which is higher on the second one. Then they tie, and then factorials pass. So triangulars are not necessarily my favorite type of number, but I will put them in the S tier of numbers, up there with, you got your natural numbers, you got, and it's, I mean, I'm not saying the natural numbers are cooler than stuff like fractions, but it's hard to make ordered lists of the fractions. There are ways to do it, but of the like classic sequences, the natural numbers and the triangular numbers and the factorials and the primes are definitely among the S tier, top category. So now, what was I going to say about the triangular numbers? I was going to note, oh yeah, the highly composite numbers was actually what I was going to note, which is that with highly composite numbers, hundreds are stealing too much credit from them in our society. We're making things in boxes try and fit in hundreds when boxes don't fit hundreds as easily. You have to like spend a lot of time as a company trying to make your box have 1,000 things in it because it sells better in our system to write 1,000 than a more practical number that the box would fit better. So if you ever see a box with something like a number like 1,080 things, that's actually incredibly practical. That means they're fitting things based on logic and not based on our society. So with highly composite numbers, the reason I was thinking of them is that this channel, thank you all so much for your support. It's crazy how fast this channel's going. This channel's about to pass a highly composite number. Let's see how soon and close we are to that. So it's actually the highly composite number. Part of the reason I mentioned the factorials too is that it's the highly composite number that diverges from the factorials in a way, where the first 7 factorials up through 1 times 2 times 3 up through 7 being the 7th factorial. That's what's 7 factorial? That's 5,040, right? Yeah, 5,040 is 7 factorial. Classic number. I just wanted to make sure that was the 7th one. Now, this is a highly composite number, more divisors than any smaller number. It actually has 60 divisors, I happen to know, because it's a great number. And after that, the 8 factorial is, I think, 4,300 or something like that. I mean, 40,300 or something like that, 40,320, maybe something along those lines. I don't know. And 8 factorial is not highly composite because it doesn't have more divisors than some guy that's like somewhere around 4 times that. Maybe exactly 4 times that, but or 5 times that. Yeah, maybe 5 times that or something. Um, or I'm 6. I don't know. There's another one that beats this one. And then what's the next highly composite greater than 8 factorial that is bigger than 8 factorial a bit, but does sneak on the list right after it and is highly composite, although not factorial, is the first number with as many factors as a billion. So you might be like, wait, how is the next number after 40,000 on that list going to beat a billion? Because a billion sucks. A billion is a base 10 based number that is not that practical. A billion is divisible by lots of twos and lots of fives and nothing else. I mean, things composed of twos and fives is all that's else. So a billion happens to have exactly 100 factors, 100 numbers that can divide it. So does 43,000, and I'm going to have to look up the rest of this. Let me pull up my highly composite numbers list. Wait, no, it's 43,360 maybe? Let me see. 45,360. That's what I meant. 45,360. So 45,360 is the first highly composite after the first factorial that didn't make it on the list. It's not really the one that stole the credit from the factorial that was more divisible, but story for a whole nother day is that the reason the factorials fall off from that list is because they're not threeven enough. I'm not joking. The factorial numbers they start building a bunch of other prime factors and numbers that contain a ton of twos faster than they start containing the amount of threes that the most divisible numbers contain. So highly composite numbers, which are the most divisible numbers by many standards, they diverge or they stop including the factorials because the factorials weren't threeven enough. So this is the number we're passing pretty soon. Let me see how close we are. Thank you to whoever watched a bunch of shorts on the plane. I do plan on getting back to making a bunch of shorts too, and next year they said they're going to start letting you make any money off the shorts. Now the crazy thing is this channel gets so many views on the shorts. There's multiple that have gotten 1 million or more views. But and so you've seen like the subscribers flying up, but they don't count like any of those watch hours as letting you get into the partner program, the ones that were played through the shorts page. Or even a lot of the live stream hours, unfortunately, that are watched live, they don't count all of them. They have a weird system for that, from what I can tell. It has like small amount of watch hours of what they count for the partner program on this channel compared to how many it's gotten. This channel's watched for so many thousands of hours and they don't count them. So that's unfortunate, but that is honestly part of the reason why I'm dropping more random longer videos on here too, in addition to me wanting to just have a good excuse to talk about things like how many things are in a grid. So anyone who watches any of the non-short videos on here, that's helping even more, like rewatching streams after or watching videos like my grid one later. Having those running does really help the channel right now. Not because I'm trying to like get much money out of the channel. I actually haven't made any money from Combo Class yet. It just got the main channel on the monetization program recently. But it's just because I want to be on the partner program for when like they start monetizing shorts and stuff. I want to be ready for that. Then eventually, when I turn this into my full-time job, I will have new shorts every day, and I will have new episodes, full ones every 6 days, which I'm already trying to do, but we'll see if I can keep it up forever. Once I make it a job, I probably can. And I will live stream a lot of days because it's also fun to do this. Now, I also want to get you guys onto the view where you can see my computer screen sometime, where my face is just in the corner. I'll get that set up later. not today, but another day, because I want to show you guys some cool graphs sometime soon. You ever seen that website Desmos where you can just, it's like a really good graphing calculator for free to use online? Well, you can graph really cool shapes on that if you know the right things with like sine functions and tangent functions and cosine functions and stuff. And like just like messing with a few variables, you can make really cool patterns. So I want to show you guys that. I also might show you some very rare old flashback footage sometime if I have you logged in, like watching my computer screen, because I got some rare files to show you guys sometime. Um, in any case, let's see what's going on in these comments. Um, Someone said creator funds for shorts are terrible. They're actually non existent on YouTube, apart from a bonus thing that they reach out to you if they want to give you money for that you can't apply for. So it's actually non existent until 2023 that you can make money off shorts on YouTube, unless they reach out to you in a special way, which happens to people with way more subscribers than I currently have. Um, it's unless they reach out to you. It's like this special thing where they're like, the shorts bonus or something. We'll give you a bonus. We'll reach out to you if we let you claim a bonus for people with like an insane amount of views. But that's why the shorts here, they got started relatively recently in the long scale, so they said in 2023 they're going to upgrade stuff. I don't care because I like making them anyway, but it would be kind of cool to be on the partner program just to like have that set up. I have the main channel on there, but I don't really care about making money off it right now. I still teach some private students, and these videos are very low budget. I'll probably try and make grade -2 higher budget, but I only spend a couple $100 making each full episode here. So I make it work, but you know, it'll be a lot easier once I can make that work. Also, a lot of people have asked if I'm going to start a Patreon or something. I actually am going to at some point, but I want to make it worth people's time. So I want to make tiers that are related to like you actually get private meetings with me where you like I teach about certain subjects. You get to like log into meetings that only certain people have access to that are more like private lessons with me. Maybe some tiers would even be one-on-one meetings with me to learn certain things because I am a teacher at heart in a lot of ways. And possibly offering tiers that like put your name in the description of full videos or maybe even the credits. So I'm thinking about what would make that worth people's time. Um, but right now I just try and make the videos work myself. And it's working so far, and we're just in grade -1. And each new grade, as people were wondering, may start somewhat randomly and it will go backwards in number because you guys have already done grade 1, 2, 3, and so on, you know? At least I have hope you guys did at least 3 grades, unless you're younger than that, in which case I hope you will. And so we're going to go negative. We're going to go deeper with each grade. And that may mean at times it's more complex, but it won't always. At times it just means we're going deeper down the rabbit hole of comboness. And each grade may have some upgrades. I'll probably get a new desk and a new lab coat once they're fully destroyed. Um, but we'll see. We'll see what makes sense. So let's see. Someone's saying that the shorts are mostly to compete with TikTok on YouTube, and that's true. That's what YouTube's trying to do. I don't know if they're going to succeed because a lot of kids are using TikTok these days, and YouTube has succeeded at being the big scale, like longer video, home created platform online. So I think that they may very well maintain that place in the market of being the go-to place for a lot of long videos, apart from like Netflix and stuff. However, I think that I don't know if they're going to take the shorts market, but we'll see. I like YouTube the most, so I don't mind that it's doing well on here. Actually, my TikTok page until last week was the most followed combo class place online, and this channel passed it like last week. But there are 33,000 combo lords on TikTok as well. So shout out to those combo lords as well. It's actually a very different range of people than here because a lot of them don't switch over on the app. There's a very low retention rate for people going from there to here. I usually just, they get discovered kind of separately. But in any class, they're just getting to learn stuff. So that's the important part that I'm teaching. Someone's asking, they missed the answer about what base 3 halves would translate a number to. Now, if you go back, it takes like a day or two for the chat to reprocess. But if you look back now, the chat will probably be reprocessed. I didn't answer those questions because I'm going to make a full episode. That was sort of like when I was having you guys go at it yourself to figure out with base three halves. But so I didn't actually double check if any of your answers were right. I just had to run inside to get the bubble charger and stuff. And the Goosebumps books we read. And so I just had you guys do some fun thinking for your brains. So I don't know. You can go back and see if you agree with the chat comments now that they're loaded on the old one. I don't want the chat to be like imprinted on the video. I prefer it to be the place on the side like this. And so to have it not be imprinted on the video, for some reason, it takes a long time to load after the stream to like put up the side one. So if you rewatch one of my streams, you might want to like wait half a day, then rewatch it because then you'll see the chat. I don't know. So let's see. Someone's thankful that I put them on do palindromes. Yep, and they will continue to appear again. There was a whole palindromic episode, but there was also an appearance of them in the continued fractions episode. And palindromes could come up in the future too, because palindromes are interesting. They relate to symmetry and various things like that. So there's something sort of palindromic about some investigations I may do in an episode soon about what it means to be sort of like an inverse or opposite element of a number or of a concept, and what it means to be identity elements and other mathematical terms, but in my way of teaching. So palindromes will return. But actually, you know what? Let's try and switch over, guys. Like I mentioned in that video, I'm going to be a little more confident about it now. Palindrome should be a palindromic word. Palindrome should be palin ilap, because that's palindromic now. Now, the only question is whether plural, you put an S at the beginning too. And I think so. I like it. I'm going with that. That wasn't in the episode, but I'm deciding that now that I'm going to say we should call palindromes palinolap because that's palindromic. But if it's plural, they're called spalinolaps because then we keep it palindromic. All right. So, yeah, I agree. Palinolaps are pretty cool. If you want a longer name, you could have gone with palindrornilaps. However, I think palinolaps is long enough. Someone said don't upgrade the set. Well, the upgrades will be that eventually I'll need to replace my desk, that I want more plants growing here, that I want more clocks hanging different places, and that it would be good to have in future grades sometime, in grade -2 or grade -3, it would be really good to also have an indoor set better, because out here sometimes it's really loud for some reason, like really windy, or it's raining, or the neighbors are doing something crazy, and so it's sometimes hard to film outdoors. And so it'd be good to have like a backup zone, and it would also be cool to have a place with like a big warehouse I could just do crazy science experiments in, with like a big concrete floor that's indestructible or something. So don't worry, if I ever incorporate a lot of other locations, it will return to the combo classroom at many times. So someone's saying that a good idea for something like Patreon. Magic Fellow's saying behind the scenes stuff, which is true. I'll probably add that as well. Some of my things like streams are just me ranting about a few things I was thinking about that day, and some of them I kind of save for later, don't show, and all the save for later and don't shows maybe I'll show to certain hyper fans who help me out, or to maybe people on Patreon or stuff. And people is looking at other comments. Let's see. Looking down, yeah, someone said the plural is, I don't know if Florian said that before after I was mentioning the palinolaps. If you're agreeing or if you mentioned that before. Okay, that's from Urban Dictionary. Good. So it's good that people agree. People asked if I ever took an IQ test. No, I haven't, and they're not very reliable. They're not necessarily a good measure of intelligence. They're done, for one, they rely on a very specific type of problem solving. For two, different organizations conduct them differently. For three, it's a test. It's not going to prove somebody's merit as a thinker. With that said, if anyone ever wanted to pay for me to take a real IQ test, because some real ones cost a lot of money, if anyone wants to pay for me to take a real one ever, I'll do it. because I don't, I would be interested in the answer, although it wouldn't be the answer of how smart I am in many meaningful ways at all. A lot of tests like that are overanalyzed in terms of what they mean. You'll also hear a lot of people reporting scores that they supposedly have that don't even exist as possible scores. So you got to be careful if someone's talking about their IQ. I would say, honestly, I've never met any of the smartest people in my life ever mention having taken an IQ test or ever tried to brag about anything like that. So if you find someone talking about their IQs really high, that's probably a bad sign about their intelligence. That, the best they can brag about is finding a test that agreed with that, instead of some like sharing some way they're good at problem solving or some hobby they have or something. So with that said, I would love to take an IQ test, but take them with a grain of salt. Someone's asking math or science. Math is kind of a type of science, but if we mean math versus science being more like chemistry and physics and stuff, or biology or stuff, I love both. I would say that I find them equally refreshing, but I know more about math, so I teach more about math. So I'm more prone to have a deep, unique thought about math. But other fields of science I find just as rewarding to learn about or to be immersed in. I'm a big fan of nature and of seeing different types of science in process. I do want to make more science videos in the future, and part of it is just having a very low budget, and also just what I happen to know the most about makes it easier for me to make a good math video than a good science video right now. But I do want to make science videos once I am sure that I'm making them good and I have the right, like, I'm able to like actually do cool science experiments and stuff. Um, so that will definitely be in the channel in the future too, various types of science. Um, yeah, no, yeah. Instead of a random BuzzFeed quizzes are actually the only way to demonstrate your intelligence. So those are the only accurate ones. No, obviously anything like that will be very, very off. And there's a lot of personality tests that are really off too. Like a lot of people really like that Meyer Briggs one where you say like something like, when I tried it once, it said I was INTP, I think, but that I'm sure would read different now. Like when you look at it, it's so biased that it's almost like a horoscope, and it hasn't been proven to have any merit and consistency. So stuff like that is like, don't take that as like what my answer is, because it would probably be different now. They're like, the chart is so vague that it's almost like reading astrology. So don't really put too much stake in anything called a test or a quiz unless your goal from it is to learn about a certain thing, not to like know about what you're good at necessarily. You can know about what you're good at kind of just by doing a lot of work in the world and observing what works well with what you create or what you help others build. Um, so let's see. Someone asked what my dream is on this channel. I have very big dreams, so I can't fully go into that. But I would love for my main channel to be somewhat like a TV show that people look forward to watching, that has cool, cool visual stuff going on, cool humor and surrealness mixed in and stuff, and ways that I think art should look like. But also teaching a really cool thing that could be shown in a classroom or something. So I just want to get my videos higher budget and higher scale, work with more editors to make them come out more often, and just have the ability to have this be my full-time job, learning and teaching and trying out different weird experiments with you guys. But I also want to, with the combo class name, build a whole comboclass.org that I do own the name for, where I'll put a lot more writing stuff and other learning interfaces. And I want to, have various ways that I try and teach people, many of which will be videos, but I also may at various points do things ranging from writing books, both fiction and math related, and writing things possibly like shows or cartoons, possibly making games or science kits. So maybe even making like science centers or camps. So I have a lot of ways I want to try and teach people. I also have a lot of other weird types of art, so I'll probably at some point make music videos and stuff on this bonus channel, because I also do a lot of music and stuff like that. So there's a variety of things that I want to do on this channel, and we're just in grade -1. We're just getting going. So Um, let's see. We got oh yeah, the funny thing about horoscopes at one time, I had a coworker at my old job at a music shop who was really into astrology and stuff, and she was like, "Oh, what's your zodiac sign?" And I was like, "Why don't you try and guess? You've worked with me for a while now. You could probably guess. Maybe you won't get it on your first guess, but like if they describe your personality, you'll probably get it within a few guesses, right?" And she's like, "Yeah, I'm sure I'll get it within a few." And you know how there's 12? It was her 11th guess was the right one. Of like trying to match them with the personality they knew for me. So I would think it would be pretty unlikely if something like the month you happen to be born in had that type of effect. I actually would believe more that based on where you are in the world, if you grew up as an infant when it was summertime or when it was winter, may have a different effect on you. You may be able to, as my hypothesis, observe an effect like in a given time zone, these people in this time zone, these babies may be a little different because when they were this age of development, it was dark versus this other age, it was lighter or colder or hotter. And so that could be possible. But horoscopes are supposed to be applied all across the globe where different months are different seasons. So it does not make sense. Um, so let's see. Yep, some more comments agreeing with various stuff and probably some more questions I've missed. I'm not going to always get to all of them. I might have to grab some water in a minute because my mouth's super dry, probably from the whole still recovering from COVID thing, which, like I said, luckily no one in my family got super bad. I think yesterday I was feeling pretty bit worse than today. So I still today have like some chills, I have a bit of a cough. I have get it like sweaty in between the chills sometimes and achy, but it could be a lot worse. So stay safe, everyone. Still viruses going around. If I go in a super busy store, I still sometimes wear a mask, even though it's rarely required in stores if the store is busy enough, because you want to be safe. I dodged this for long enough, and then it finally got me through. Um, who knows? My family all have jobs different places, so someone in my family got it at their job. Um, and we all got sick because we have a small house, one at a time, and I was last. But luckily, not too bad. Could be a lot worse. So let's see. Thank you to everyone here and elsewhere who has wished us well. I was actually most worried about my mom, who was probably the most at risk out of all of us for it being bad, but she has already passed the worst of it, definitely, and definitely on the upswing. So we are doing okay. Someone's saying I'm inspiring them to be a math major and they're a welding associate's degree right now. That's pretty awesome. I don't want to recommend anyone switches career paths because I didn't even major particularly in math. I took a lot of classes in it, but college isn't where I learned most of my things. However, I am going to recommend that, if math really compels you and you want to spend a lot of time learning new parts of it, maybe a math major is the right thing for you. There also could be cool ways to mix that with welding, as any two things that you're into, it's fun to try and find the merger between them, and that can sometimes be extra unique. So, for example, like if I'm into math and into music, trying to find ways to describe music with math or vice versa can be a cool, captivating in between. So, math and welding, maybe you can find ways to do some math behind if I put the welder here at this thing, what shape do I get? Or things like that. Probably a lot of geometry there. So, let's see. What are we going to talk about now? I think I do need to maybe grab some water in a second. My mouth is super dry. I theoretically could drink from that hose, but I'm not going to because that hose is, I don't know, like how dirty the inside of it is. Um, but good thing we do have a working hose back here. So if you ever see any fire action, don't worry. We have a very good hose ready to put out any fire that you may see. And of course, don't copy that. I did have fun lighting a pumpkin mega on fire on the main channel in the newest Halloween special. But as I tell people, do not copy me. Just watch me do it and you learn about math. Um, I mean, you can copy me with the mathematical knowledge part, not on any of the fiery clock breaking parts. Florian's wondering my opinion on AI generated proofs. And it's a great question I kind of brought up in one of the earlier streams about whether we should trust the validity of a proof that's too long for a human to ever check that a computer says is correct. Now, I would say that if just one program said it was correct, I would be a bit skeptical. If there was a way to build a few different computer programs with mildly different approaches from each other and maybe run on different computer softwares that came to the same conclusion, then I would think it's pretty likely. And everything we prove, of course, is only a 99 point some amount of 9% proven. There could always be some weird glitch in the system. Now, there's a ton of nines after that decimal if you're saying something like 2 plus 2 equals 4. That's debatably 100% proven. But things like even gravity, like obviously I'm not saying gravity doesn't exist, but we don't say it's 100% proven because, it's good to just, as a scientist, be honest and say 99 point, how many nines are we sure? And there's a lot of nines for gravity. So, when we prove something, I would say maybe I would give that we're 99% sure on that if one computer that likes it. And if multiple of them maybe agreed to it with slightly different approaches, I would say it's a pretty safe bet. However, it's a little different. It might even need a name for it. We probably should name it something like this was mecha proven or something like that. And then we'll use like mecha proven to mean a certain type of proof that you can trust if you want and not trust if you don't want. um, yeah, so the next comment was similar to that. So that is interesting. There's a lot of really long ones. Now, one of the coolest proofs that I do want to sometime try and dive into, not because I'm going to understand most of it, because I want to see what parts I understand, is the classification of finite simple groups. A 10,000 page proof written by many authors over many years that they're trying to boil down into a smaller proof and having difficulty getting smaller. And it's basically a proof that a certain set of things is complete. So it took them a long time, but the set of things they're describing is group theory and the simplest one category of groups in it. And that's a very big field that describes the inner workings of lots of math. So that would be a fun one to try and jump into sometime. There's also the world's shortest proofs. I mentioned in one video, I think, where there's a conjecture by the great Euler that when you look at a lot of numbers, it seems likely that you have to add up two square numbers to get to another square using different ones than the same one equals one, obviously. You can add up three cube numbers to get another cube, but not two. And that's true, his conjecture there. Oh, whoa, Sage, are you up in the tree? What are you doing up there, mister? What the heck? Wait, I need to get you guys seeing this. What are you doing up there, dude? Whoa, that was quite a leap. I don't know if you guys saw that. He's very nimble. But well, I completely lost track of what I was saying. I haven't seen him go to that part of the tree before. Okay, I must have been saying something based on one of these. Oh yeah, shortest proofs. One shortest, okay, no, this isn't a proof necessarily. You wouldn't say, but it was the shortest mathematical paper at the time because it was, or like officially published paper, because it was a counterexample to a conjecture by such a great mathematician and such a seemingly true conjecture that it was a famous one, which was that it would take 3 third powers to make a cube, which is true, that it would take 4 fourth powers to make a fourth power and 5 fifth powers added to make a fifth power. But you can actually do some of those with less, not cubes, but some of the others. So we actually, there was a paper that these guys were like in 1 or 2 sentences basically said like, we have found a counterexample to the conjecture from Euler that da 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 da. The counterexample is da 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 da. And that's the end of the paper. There's an even shorter one that was attempted to be made by John Conway and some others, where they were trying to use a diagram along with a single sentence to make a paper, and it's pretty interesting. I haven't shown that one here yet. Sorry, Anand, I'm not going to integrate your homework or whatever that is, but thanks for asking. Someone's saying if exponents are repeating multiplication, what's repeating division? Well, you could say that repeatedly dividing something could be seen as dividing something by an exponential thing. Like if I'm saying 2 times 3, and then I'm saying what's 2 to the third power actually? Now it's instead of 2 times 2 times 2, or yeah, 2 to the 2 times 3 meant I had 2 plus 2 plus 2 3 times. 2 to the third power means 2 times 2 times 2, and I have 3 of them total. And so if I said 2 divided by 3 repeated, it sort of depends what you mean by that. Do I mean like 2/3 to some power, 2/3 times 2/3 times 2/3, or do I mean 2 over 3 times 3 times 3 times 3? If I mean just making the bottom get bigger, then it's sort of like I'm taking 2 over a power of 3 or something. But so it's a bit of a different story, but there's a few ways you could analyze it. There's another way that a square root is similar to repeated division, although a square root is really similar to a fractional exponent, and in most cases synonymous. In most cases, the square root of x can be rewritten as x to the 1/2 power with no issues, if we mean the positive primary square root. So let's see. So yeah, that's what x to the power of 1 over y. That's another way that we could look at expanding that thought. Now, one that I want you guys to think about that'll show up in an episode soon is what do you think are the opposites of the number 2? Well, two very obvious answers are either -2 or 1/2. What makes those so opposite-y with 2? That's just something to ponder, because I do have a way I want to express my answer that I'm saving for a full episode. Although our next full episode will probably be related to, oh no, the next one I already have filmed that I got to edit. But the next full one I film next will probably be about if we counted in base -10 or in base -2. Not making the number -10, but counting in base -10. So that's pretty wild. Someone is saying, what type of math fascinated me to do what I do now? I loved all sorts of numbers and shapes and things. One of the first types of math I actually fell deepest in love with was logic, and propositional logic in specific, of how things being true or false imply other relationships between them, and strange things you can do with logical sentences and descriptions of things. So I really liked that, and I liked all sorts of numbers and shapes. So looking back, at first, sometimes I feel like more recently I went extra deep down the math rabbit hole. But there have been various times in my life I've gone deep down that rabbit hole, including as early as like in middle school, starting to try and find the golden ratio myself and doing Rubik's Cubes with friends and memorizing pi and stuff like that. Lots of types of math. Someone said, do I have something interesting to break something to break their classmates' brain that isn't too crazy? Hard to say what they would consider too crazy. I don't know. You could how about this one? This one's will shock a lot of people. This will also show up in the video about these shapes I just put on this channel. Is if you take any numbers, I'm going to write them as the first, we'll go up to 4. If I go 1 plus 2 plus 3 plus 4, and then I square that, I happen to get 100. And that's, like I said, one of 10's cool traits is 10 is the first four numbers added. So this squared gets us 100. But I can also write that 100 as 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. Does this tell us 100's special? Nope, 100's not that special. This tells us that the sum of the first n cubes is always the sum of the first n numbers altogether squared. Pretty wild, huh? If I wanted to find out what it would be like if I snuck a 5 in there, it would be the same question as if I added a 5 cubed at the end of there. 5 cubed is 125, so the answer is 225. So that's kind of cool. One that if you want to see applications of that as a fun puzzle, look at my shape counting video after this stream. As soon as it gets too dark here, or maybe I'll bring some candles or something. We'll see. Maybe in a minute I'll run and get some water and some nice spooky candles. Okay, maybe it was actually a good day to give that preliminary. If there's fire on the set, don't worry, I have a hose warning. So let's see. Someone's saying that Gauss discovered the fast Fourier transform but didn't publish. That's wild, but I definitely believe it. I'm still learning some of Gauss's great work, but I would put him for sure on, in my opinion, top 10 greatest mathematicians all time. I would put him, in fact, maybe top 5. Gauss did a lot of great stuff. So someone's, well, if that's kind of comprehensible, but they're not the brightest, how about this one? How about good old 1 plus 2 plus 3 is 1 times 2 times 3? They better get that one. So someone's saying that's crazy. It's light where I live, but dark there. It's barely light where I live. It's getting pretty dark out here. Someone said they thought I was just playing a character. There may be like moments where I feel compelled to ever so slightly exaggerate my mood when I'm on camera, but it's definitely all just me. I'm just a weird guy who does really like math a lot and talks a lot and stuff like that. So I think it is candle time, but let's see. I don't know. If I hear 3 votes for candles in the comments, then I'll go on a quick mission to get the candles, and you guys got to hang out while I give you a math problem to talk about. So let me think of what my homework would be. What's a good math problem to chew on? All right. Someone was saying they were thinking the one about how half plus third plus a fourth approaches infinity is a good one. That is also a very classic one. If you that's probably more confusing to grasp. A lot of people don't even believe it when I tell them that the harmonic series diverges. No, I don't have any math degrees. I went to college for a few years, but I ended up leaving just to like work on other stuff. I've learned my stuff other ways through reading and writing an absurd amount and through working with different people who like math and stuff. So I think I am going to run and get some candles, even though no one was voting for them. Since I'm going to be gone momentarily when I get the candles, what I'm going to need to do, and actually, I think I only need to get a lighter. I think I left some candles out here. So if I run and grab a lighter, I can cast a little light on this scene. I'll do it safely. And then we can chat a little longer. But in any case, I wanted to give you guys a fun little problem to chew on while I'm gone. Here will be your question. Let's see. So this will be a good one, similar to a challenge we did in the past. But here's my question. for you guys. If we were to count in base -10, and here's what that means. That means that this place is still a ones place because that's -10 to the 0th place is 1. This is our base square or our bases place. So this is how many -10s we have. But then normally we get our 10 squareds place. -10 squared is the same. That's a hundreds place. This is -1000s place because -10 cubed is negative again. This is +10,000s place. So here's going to be your guys' challenge. How do you write the numbers between 95 and 105, those quantities of items in base -10? And the way, if anyone's up for this challenge, what you're going to do is try and write in like parentheses what number you're talking about, and then write how base -10 would interpret that. Now, this is way too dark to see. So hopefully, if anyone wants to play that game while I run and get candles, you can remember that. But I'll be back with a lighter in 1 sec. And I've returned. All right. Someone's saying 95 would be 105. Not quite. I'm just going to show 95. 95. And you don't need to use negatives. Someone was trying to use negatives. Good guesses on those, but we don't need to use the negative symbol. To make 95, I need to put 100, 1 minus 10, and 5 ones. So 115 is how they write 95. 100 minus 10 plus 5. So that's that one. How would they write 105? The one on the other end? They would just write 105. That one works. So 105 we would get to be the same because it's only using that place and that place. Now, if we want to do something like 85, that would actually go to 125 is how they'd write 85 because it would be 100 minus 20 plus 5. So pretty weird, but kind of cool how with just positive numbers, I can make positives or negatives. And you'll notice a pattern that for generating whole numbers in that base, or even in any negative base like that, that a number you see in that base with an odd number of digits is a positive number, and a number with an even number of digits is a negative number. So I need candles, obviously. It did get way dark way fast on me. I just keep these out here. So let me melt them into the candle holder real quick. Now remember, I'm cautious when I have candles out here. If you ever use candles, good not to take them out of your sight. You don't want to leave an outdoor place with candles burning unattended. Because fire can be crazy, even though I may unintentionally make it look fun sometimes. Remember, it is a dangerous, powerful thing. It's one of the elements. I mean, the four elements are a little overstated in past antiquities culture, but there's something to be said for fire, water, earth, and air being pretty present in our world. Those will show up as well in the next full combo class episode. That's the longest one yet, I think. I'm editing that right now. And it is called the Mysterious Hyperdice Sequence. So one more candle to get in this holder, and then we will get a little better lighting on here. Sorry if I've scared everyone away with the darkness and the vanishing, but we still got some combo lords hanging around. And so why not have some more time in my half-sick evening hanging out with you folks? All right, come on. I want to get this sturdy enough to not fall on me or anything. You know that trick where you light at the bottom of the candle and then you drip a little wax into the candle holder, and that affixes it a lot more. Gives it a nice little base. So that's what I'm doing right here. Just dripping a little suction cup at the bottom to hold it in there. Now we can actually light the candles, and I'll find a good place to put them, which I probably need another chair for. Also, when it gets windy out here, it's probably just going to put out the candles if it gets windy tonight. By the way, I found this cool thing when I was using candles the other day that I don't think I'll show today, but it was like one of the wicks got folded back on itself, and the flame was super big because the wick size turns out to be pretty dependent on the whole flame size. And when one of the wicks folded on itself, it made the flame monstrous. So this will give us a nice spooky post-Halloween vibe. Let me get a second chair to put these on. And there's already one out, but I think once I set them down, they'll be okay. So it is still Halloween season. I still have pumpkins here. I'll put some pumpkins and candles on this chair to give us some good Halloween passing nostalgia. Now, if anyone did anything fun for Halloween, leave it in the comments. And as well, I can see that these may not be enough to light the whole scene. I should get like a whole candelabra lantern or something. So yeah, it's still very dark. Let me see if I can get those closer to me and make this work a little better. There we go. That works. Got a little candlelight chat right here. Can't see the pumpkin, but that's okay. You can trust me that the pumpkin's hanging out in front right there. This little one was actually harder to carve into a jack-o'-lantern. I might still do it for fun, but when I tried to stick a knife into it, it was like really firm. It's not as designed for carving as the big one. Was so easy to carve into. It was like made for that. Like they make pumpkins easier to carve these days somehow. And so like these pumpkins, they're not designed for flavor if you wanted to cook them into stew or stuff. They're just designed to be these big hollow, like not as much gunk on the inside, like really stabbable things. So that worked pretty easy on the other jack-o'-lantern I had to carve in my Halloween special. Someone's wondering about a short with that concept. And yeah, some of the bigger concepts I have, if you mean the negative bases and stuff, are things that I want to make full episodes about. So sometimes I've held off on shorts. Sometimes I just make a short about it anyway, even if it'll show up in one. But in that case, since I'm going to be making the episode soon enough, a short about that will probably be like a trailer for the full episode. So usually I take a few fun facts out of each new full episode to drop as shorts around that time, half as trailers and half for people who don't have time to see the full episode to get without spoiling the usually it's not like the last thing you learn in the episode, so there's still a few like secrets to learn when you watch the full episode. But usually some of the like non-main or last fun facts, I will make little shorts out of as well. So I'll probably give some fun examples of base -10 then. Now, don't even get me started on fractional bases. That's a whole nother story. Um, so, whoa, this is really weird. These are making like heat waves, kind of, or whatever the term. I don't. I guess it might be a heat wave or some type of like. Um, basically, when I look like through the candles, like I kind of have to right now, the text is like waving, like a heat wave, kind of. Someone's saying try carving a chili into a jack o' lantern for spicy Halloween. That's a good idea, except that if you burnt the inside of the chili like a jack o' lantern, I think inhaling burnt chili might be really spicy on your lungs. So maybe like a bell pepper or something. I ate a chili in the Halloween special, a jalapeno, or like half of one. It wasn't the worst one I've had, but it is still a lot hotter than a pickled one. Like I love some good old pickled jalapenos on some nachos or something, but the raw ones are really spicy. But this one didn't kill me. It was I could handle that one. I've had worse. Like I've mentioned in the past, I do like trying to eat random hot things for fun. And I have one of those world's hottest spicy chips that a friend gave me that me and some friends will eat for a video sometime. We'll probably split it. I don't think I can eat it myself, but those chips that they sell to like for the point of a challenge only that like is supposed to like kill you. They put it in a coffin and stuff, but it's not actually supposed to kill you, but it basically does. Um, and so we'll see. I might split one of those. But the reason I like doing that is just for a fun challenge for myself. Not that I recommend it as a challenge, just for a fun personal thing and because I like to challenge myself, but not because I have a high spice tolerance. I really like mildly to medium spicy foods. Foods that's like medium spicy, I love. But foods that are mega spicy, I like them and I like the challenge of them, but it's not that I can necessarily like physically handle them better. I've eaten really hot chilies for a challenge before and been like on my bed for like 5 minutes, like, so someone asked what grade I found most interesting for math. Um, no, I did all my favorite learning outside of school, so that doesn't really apply. But maybe seventh to ninth grade when I was first starting to learn about how you could use this thing called x as a variable and the way it applied to like both graphs and to numbers. Start learning about squares and square roots and stuff. Um, So that was pretty cool because that was new. And there's always cool new stuff. I had a lot of fun classes, but I learned more from books and online articles and writing and thinking. Someone's asking if you can graph tetration. Yeah, if you look at the end of the tetration episode, that's a graph of it on the complex plane, and the graph's color coded as to how fast points go to infinity or not. But it makes a fractal. So there's tetration fractals that look like the Mandelbrot set. That's a certain way of graphing it, but yeah, there's many ways you could graph a tetration function. But you'd have to choose what function you're graphing. You know, I could say, am I graphing here is 2, here is 2 to the 2, here is 2 to the 2 to the 2, or am I saying here is infinite ones stacked tetrated, here's infinite twos stacked tetrated, or you know, it's not like one decision to say, can you graph tetration? It's only repeated exponentiation. So for most rules, exponentiation can just, it could be rewritten as exponentiation usually. Um, so someone's saying, let's see, put a math sentence in one next year and leave it out to see if anyone can answer it. I really don't know what you mean by a math sentence or put it in one what, but we'll see. Do I like fractals? And I do. Fractals are very cool. And I think fractals are very important to nature and science as well. Now, you got to remember that fractals don't always mean that when you zoom in, you get a copy of itself. That's one type of fractal known as self similar. And those are great fractals, extra classic ones. But there are also non-self-similar fractals, and there are measures of something's fractaliness in terms of it in a way, meaning its dimension is not an integer, is a weirder thing. And so, for example, shapes like the Sierpinski triangle or this classic fractal snowflake shape, or a lot of the classic fractals can be assigned a dimension based on when they scale up, how they iterate. Similar to our dimensions are somewhat related to if you scale up something in size, does the quantity grow linearly, squared wise, cubed wise? We call those like 1, 2, or 3 dimensional things. And so fractals can have an in between dimension. And so that's actually a key trait of them. And they're really great and they show up in a lot of stuff. So there will definitely be fractals in future episodes. Some of them I've held off on showing just because I want to wait until I can work with some cool like graphics people and programmers who can actually design some interpretations of fractals just for the show. Because I would, even though I'll probably end up showing other people's fractals and being like, I got this from Wikipedia or whatever sometimes. Um, I like the idea of including my own homemade fractals that will probably require working with others in the future as well. Thank you to whoever said I'm handsome. That's nice. And someone asked that we're living fractals, and in a way we are. And someone said, never mind. Oh, the person who said I was handsome. Burn. Wow. So someone asked about the new Veritasium video. I didn't see it yet. Veritasium's great, though. I will watch it before long. Veritasium and the guy Derek who runs it doesn't happen to be like one of the couple channels that I always watch their video right when it drops. That's like 3 Blue 1 Brown, Mathologer, this guy Stand Up Maths. There's a few channels that I like pretty much always watch their video the day after it drops. And those guys, I'm actually subscribed to their Patreons because I want to support them too a little bit, even though I don't have much money. So I get to see their videos a little early even. But stuff like Veritasium, I don't always catch up on people's videos right away. But he's great. So he's made many cool science videos and sometimes some cool math ones as well. This one looked pretty math oriented. So definitely going to check it out. He had a couple really great ones. One of his more math related ones that I definitely recommend is his thoughts on the Collatz conjecture, where the 3x plus 1 thing that a lot of people have asked me to make a video about, and I probably will once I have my own unique spin on it. But there's already been a lot of cool videos like a Veritasium one and stuff that just present the problem in a really good way. So some topics like that are highly requested from me, I want to wait until I have my own unique way of presenting them that will bring something new to the table. In the meantime, for people who want to check out a Veritasium math video, that's a great one. But not in the meantime, meaning quit the stream, or even right after, for those who haven't seen the video I just dropped on this channel, which is kind of like hanging out in a class period with me, learning about how many squares and triangles are in weird grids. So, happy Halloweeny mood again, everyone. Even though I probably won't eat any right now, it's good to know that if I wanted, I still have those weird Kit Kats out here from before, including one from like the ones that are the flavors that aren't made in the US but made in Japan and include things like a boy band guy on this one. That's kind of hard to see. There's like a little maybe like BTS member or something on this one. Well, I ate these in another stream. We'll see if I need it later. I can't send someone one. I don't even know where I got them because a friend gave them to me. But with that said, what I'm waiting for is when they import more Haichu flavors to America. I've seen the list of all the Haichu flavors they got, and they're holding back on us. They got some interesting sounding ones. Coffee Crisp, I've not had that. Why is my lab coat dirty? Because this is an outdoor classroom and I work with a lot of marker ink, and I sometimes wipe the whiteboard with it to save time. And there is paint on it because I painted in an episode, and there's scratches because I've worn it around thorns, and it protects me. It has burn marks, so it's my protective coat, and it has done its job. All of this damage would be on other clothes otherwise. So one lab coat per grade. We'll see. This lab coat's holding up surprisingly well, I would say, for being 2/3 of the way through the grade. So, sorry to the haters of the dirty lab coat, but I'll put it this way. I'm working inside out right now for a few reasons, and it's partially because there's this prickly bit when I flip it normal way where I got melted clock on it. Um, and I have my dice embedded there. Um, but it's if I wore it the other way, it's arguably dirtier. So it's debatable which side's more dirty at this point. It's kind of reversible. It has pockets on both sides. So someone said, "What's the wackiest application of math that I've seen?" Um, I don't know. I would say probably the more like wacky makes me think of something I wouldn't expect from math. And I expect math to have a lot of cool numerical surprises. So I guess it would probably have to be some way that I've seen something like magnetism do, or something like a combustive reaction do, like interesting things with science that are secretly math related. Um, so probably that, because sometimes that surprises me more, seeing a real world scientific reaction. And that's not to say that's the most common surprise I encounter. I encounter awesome surprises with numbers every day that shock me. However, the fact that there's going to be a numerical surprise, or that it'll be an application of math, is less shocking there. Um, all right. Got to move these a little bit. I'm breathing in all the candle. Someone wanted to just thank me for curiosity of sequences in geometry, and that they love the coat. Thank you. The coat tells a story. If you watch the combo class videos on the main channel, and the bonus channel has a lot of in between action on the coat, but if you watch the main channel, you kind of see the progression throughout this grade of the desk, the coat, of my hair, and of various things. So you can kind of hopefully watch the grade -1 like a TV show. And we're going to kind of hit a reset next grade where I will have a probably fresher haircut and lab coat and desk. But let me just say, don't be shocked if it gets even crazier, even quicker in that grade. Um, so um, more people also popping in and out. Thank you. I love you all. I've really appreciated all the wild support this channel has been getting recently. At first, the combo class was a lot smaller presence on YouTube because the main channel took a little while to get noticed anywhere, even after I blew up on some TikTok videos, and I hadn't started the YouTube shorts yet. Not that many people flocked over to the main channel. And then between one of the videos on the main channel about tetration blowing up, and then here, like so many shorts blowing up when I started posting these just barely over 2 months ago on this channel, which is really crazy to think about. I literally started this channel barely over 2 months ago, and I think we're about to pass our cool highly composite number soon. Let me refresh and see where we're at. Remember, it was 45360, and okay, we're at 45351. We, in 9 more subscribers, which will actually happen surprisingly fast, we are going to be at the highly composite number that I forget if I got this far or I got sidetracked, but the number we're about to hit of subscribers is that highly composite number that has as many factors as 1 billion. So even though I would use a different term for the practical billion to mean a number around that size that's highly composite, if we called this like the efficient billion or something, we can say we just hit an efficient billion amount of subscribers. Well, we're about to. So thank you all. It's so crazy and wild. I do have big dreams for this, but I didn't realize it would work out so quickly. So that's cool. Like I said, I haven't made a penny off this yet, but just having people starting to be invested here and build communities here as well. Maybe I should put in the chat here just in case anyone needs on this stream as well. But there are people posting some stuff on Reddit and Discord as well to have some cool combo class type discussions and chat with other people who like learning in a similar way. So let me throw the link to those on here too. Here's a link to, if anyone needs in the future, the Reddit. And here is going to be a link to the Discord in a second. For people who use those apps, I'm not a big tech guy, but like I've mentioned, I can enjoy Reddit sometimes, and I go on this combo class Discord. I haven't used Discord before that, but I like chatting with other combo heads. And so the link to that will be right here for anyone who wants. Um, so let's see. And yes, thank you to Pixel for that. I appreciate that you've learned a lot from it. That's awesome. A lot of my videos relate to my personal take on something with numbers that I'm just surprised I never learned until I encountered it in a few books or online weird places. Just some magical, beautiful things about numbers or shapes or science that it's like, why didn't I know this until I learned it? Why wasn't this something taught to me in the first 15 years of my life? And so those are things that I'm like, why not share these with more people? Um, Someone asked about my favorite math equation, and there's actually a lot written on the wall back there, but it's going to be hard to see that right now. Let's see if the candles can illuminate that at all. I don't know. There's equations on this wall. Um, that's going to be pretty hard to pick a favorite. Um, yeah, I can't go with one. Oh, and thank you again to Pixel. So yeah, and thank you to all the nice commenters. Probably not going to stream that much longer, but it's kind of fun getting this weird candlelight vibe out here. This is a little different, so I might roll with this darkness thing for a little bit. If we need it, can still bust out the whiteboards. You know, we always have the whiteboards ready. Remember, I bought enough to know that if they get destroyed throughout this grade, I'll still be okay. And that's why I not only have my massive one, but I have approximately 40 small ones. Um, Now, someone asked when I got my first clock. Now, obviously, I've had clocks throughout childhood, working ones, but if they mean when I got my first clock in this classroom, which was also when I purposefully got my first stopped clock on purpose, is that was when I was filming the first Combo Class YouTube episode. Because although I got carried away on this clock quest for reasons you can see on the main channel, um, there's a whole clock quest I've gotten carried away on. But I did originally like the stopped clock idea of that stop clocks are right technically more often, I realized, than a wannabe right clock. And thinking about having more of them giving me them right all the time, I was like, okay, when I make the first Combo Class episode on the main channel, I'm gonna have some stop clocks, and there is a gag in it about that. So that I filmed a little under a year ago. It was I filmed actually that first Combo Class intro, although I didn't start posting any Combo Class stuff anywhere online until this April, because I've gotten a bunch of surgeries this year and crazy stuff too. But the end of last December, like right before this year hit, was when I filmed the first intro for this combo class thing. There are previous iterations of things I'll show you, of combo things I've done in the past. But for the combo class footage, you guys know, that first clock was probably purchased in December of last year. So we're up to about 40 clocks, but we're just going up. You know, hopefully it's an exponential curve. Because if it was linear, it's going to take us a long time to get about 400 clocks that I've promised. But if we consider an exponential type of thing, maybe, like, how about we consider this? What if the function moves actually similar to squaring, like to x squared? How about? Well, we are past the square root of how many clocks we need. How cool is that? So we, on some graphs, are halfway there. But yeah, we're gonna have more and more clocks. Um, and then if you asked about other things like how many dice I've had, that'd be even longer. If you ask how long I've been thinking about stopped clocks and writing about stopped clocks, that's been longer because they have occurred in many fiction books that I want to publish someday that I'm halfway through writing. Someone asked, why do I light up the candles? Some electricity issues. I don't know if they see where I am. Ow, wax. Um, I'm outside. I'm outdoors. You can't see, I guess. Here, look. It's a plant. See the plant? Can you? No, wait. Let's get a look at a plant. Oh no, there's a plant. I'm outside. There's not a light right here. Um, so since there's not a light built on outside the part of the house where the combo classroom is, I have yet to have a good lantern or anything. I don't mind because candles are good. Candles are fun. Um, But we'll say that it's because it's still within a week of Halloween. That's why I have the pumpkin. Someone said, "Don't burn the tree." Don't worry, this staghorn fern, I would never. I had the flame at a safe distance. I love this thing. I've had friends whenever we do crazy stuff around the combo classroom. If my friends are like, "Can I hang this crazy clock off this? Can I put a nail in this? Can I hang this thing here?" I'm like, totally. Except the staghorn fern. If they're like, "Can I put something on that?" I'm like, "Nope." Staghorn fern is just a plant. That is just a magnificent plant. And that thing's been here since my family moved here, and it's just like this awesome thing growing off the wall. You'll see better in the daylight. I'm gonna try and figure out how to give it better water when it's not raining, like maybe mist it or something. I think because you're not supposed to fully water it, but maybe misting it, it'll get even greener and more luscious. But it's a really cool plant. It also has my grandma's ashes on it, among other places in the yard that I scattered some of them. So this is a very important plant to me. So and yeah, I am where I film my videos. It's just really dark out here right now. I'll probably stream in my room at some point, but my room's so tiny and crowded. I haven't thought about setting it up for streaming, but I can make it work. I can get this same webcam set up in there and probably do streams in my room at some point. Maybe out here will be the more scientific streams, and in there will be like if the type where like I'm smaller in the corner and we're looking at me learn some facts or write some facts or something on the computer. So yeah, there'll be some indoor streams sometime too. A lot of you may have never seen my room. Actually, I don't know if any of you have seen my room. All right, no, there's been like one or two videos filmed in my room. So if you look long and hard on the bonus channel, you'll find one or two videos filmed in my room. So any super fans who somehow know, leave a comment with what color my walls are painted. Now, you may have heard me mention it in a stream too, if anyone happened to know. It actually has a good name, is why I may have mentioned it, for the shade of the main color. But even just what color it is, you will see soon. But I'll give you a clue. It's my favorite color. A lot of these are questions I get a lot, so I can't keep answering them. But that's why, in addition to like the video I made today on this channel, where I'm just like a one take longer lesson about counting grid shapes, I'm going to do more like that aren't streams, that are just like a long video essay rant about a particular thought about like, this is my explanation of where I learned certain things. This is my explanation for was math invented or discovered, or stuff that I get asked a lot, and then I'll just be able to point people toward those answers until the answers possibly update, because opinions can change. But those are questions I've answered on stream a lot. Although underappreciated mathematician, I guess, wasn't as asked. I've talked about my favorites a bunch. The most underappreciated, that's going to be hard to say, because logically, the most underappreciated one would be someone I don't know. So it's a kind of paradoxical question. Or someone I know and don't appreciate. But I would say that the ones that I know that I think more people should appreciate would include Ramanujan and would include John Conway. Those are, and would, out of modern people, not really underappreciated, but for people who haven't looked at as many modern people, Terence Tao. Now, someone's asking royal blue. Not quite, but good guess. I'll tell you anyway. The shade is called lizard green. But yeah, you can get to see my lizard green walls in the future. There's also some cool artwork and stuff hanging. Someone's saying quadratic equation, go. If you mean the one with the A's and the B's where you write out the whole quadratic formula, I'm not going to go through that right now. That's actually not, in a way, the coolest or most applicable formula. It can be useful, don't get me wrong, but usually when you encounter something you need to solve, there's a niftier way than trying to plug it into that messy thing. But it's still useful. But it's overused in school. That is one of the things that could maybe be used a little less. Is, do you know how to plug this into the quadratic formula? Do you know how to plug that into the quadratic formula? That might be a little overused in school in terms of like not giving them time to talk about the stuff that's in my videos. A lot of the stuff in my videos, I really don't know why you don't get taught it in like middle school or high school. And then everyone is going to have their own like 10% of the videos they were taught by their teacher, because some teachers do weave in cool stuff. But there's also going to be a lot that people were never taught, that it's, I think, more fun facts and magical connections of those fun facts should be weaved in. Um, Now, let's see. I mean, really, if you want to build mathematical curiosity, there's some mathematics that helps for applied science. But if you're teaching people about like prime numbers and stuff, that might be more for pure maths than applied science. Not saying it's only for that, but the more you go into teaching pure mathematical stuff, it seems like the main thing you want to build is curiosity, because memorizing something in school won't necessarily stick, but you want to build a love for the thing that makes somebody want to pursue it, because the people who solve great equations are people who, for some reason, usually based on enjoying it somehow, were motivated to spend many hours a day working on it. So I think schools should build a lot more curiosity and problem solving. Although that's a kind of like over said answer. So over time, I'll explain more about how can we actually implement more curiosity and problem solving. But the first step is just to show more fun facts and connections between them. Someone asked if I do any programming, and I don't really. I've dabbled in it like at various points in my life, ever so briefly, but not in a while. I more want to work with other programmers so I can spend my time like learning and writing and stuff like that, and making videos. But I do have a lot of sequences that I want to work with more programmers to test. I might end up learning some programming on my own, but it'll probably be more of a collaborative thing. Someday on my team, I'll definitely have programmers I'm working with to test out my weird sequences I've invented and such. And by invented, obviously, other people may have stumbled into them too, but I mean like sequences that I haven't found an answer to yet online. Um, Someone says they knew about 265 digits of pi and only know about 55, and that's a similar ratio probably to me. I used to know 100 in middle school. We memorized 100 digits after the decimal for fun, me and my friend group. However, okay, no, not the whole friend group. Three of us did that for fun. But now what I know is 3.14159265358. I want to say 9793, something like that. I've missed some twos maybe. So I got a good chunk. The beginning's definitely 3.141592658. But I used to know 100 digits, and now I don't care about trying to keep that memorized, but somehow that first string is just stuck in there. I'll probably I don't even like remember anyone's phone number. I remember like three phone numbers total, because contacts do to that to you with names. So I only remember like my best friend and my mom and my brother's phone numbers. But I remember that many digits of pi. Wow, great use of brain space. But whatever, it might come in handy. Speaking of which, a fun thought I had today was, which I'll put in a longer video, but just to weave in this fun thought I had. I was thinking, do circles actually exist in nature? And it's a very classic debate that we may never be able to prove. Like if a pure circle exists in anywhere in some fundamental thing in the universe, or if everything is only a rough approximation of a circle, meaning pi itself never shows up exactly, that precise pinpoint of an irrational number, exact string of infinite decimals, that might not ever show up in nature. However, couldn't you say that as things get more circular, since it approaches as a limit, that being included in the equation, you'd have a coefficient in certain perimeter and area functions of even almost circles, that the more circular they get, something would approach pi, or for higher dimensions, something sometimes pi squared or other stuff. And so couldn't we say that pi definitely exists in nature, because it at least exists as the limit as things get more circular in any dimension? So that was just a thought I had today. And that applies in different dimensions. And for fun, since I was looking at this today and I do have a list pulled up, let me note that, so in the second dimension, you're used to a circle has an area of 2 pi r. Let's actually for now call that the volume of the circle, even though technically it has no volume because we use that to mean 3D. But let's right now use volume for a second to mean the innerest component, kind of. So like a 4D hyper shape has like 3D outsides, but an inside hyper volume, we'll just call the volume now. And like a 2D thing just as an area, we'll call the volume. So we're going to mean like the innerest part of it. Well, a circle has a volume area of pi r squared. What about in the third dimension? Well, we get 4/3 pi r cubed. Then in the fourth dimension, turns out we get pi squared over 2 times r to the 4. And as we go to the next even dimension each time, we see another power on the pi divided by something too, but a power on the pi going up, like pi to the cube, pi to the fourth, with every new even one. In between, they have the same one as before with extra weird coefficients of integers. So for example, like the 10th dimension is pi to the fifth over 120 times r to the 10. And the 11th dimension is 64 pi to the fifth over 10,395 times r to the 11. And yes, I'm reading these from a list. These I don't have memorized. I just had the list before I was filming right here. But here's the weird thing. So these are volume in terms of radius. And by volume, we're meaning this hypervolume of the innerest thing at each level. So here's where it gets weird. If we have a radius of size 1, then the end bit that says r squared, r cubed, r4, or whatever, is always going to stay the same. So if we're talking about a circle, sphere, hypersphere, hypersphere, and so on with radius 1, the r is always constant there. And we're just left with that front bit, pi, 4/3 pi, pi squared over 2, something like that. Now, what are those? Meaning, what would the volume of a ball with radius 1 be? Well, in the second dimension, it's just pi r squared, it's just pi. In the third dimension, 4/3 pi is a bit higher. It's about 4.18. In the fourth dimension, pi squared over 2 is a bit higher, 4.9. So we could see for a while, it's like, okay, cool. We are increasing as we go up in dimension, the volume of our one radius hyperball grows. But the fifth dimension was about 5.264. The sixth dimension, where we're at pi cubed over 6 r to the sixth, our one radius ball has a hypervolume of 5.168 and a bunch more. These are the approximations, the first few decimals. And so it goes down. The hypervolume's smaller comparatively for the one radius ball. And it continues to shrink and shrink and shrink and shrink. And it gets smaller than 1 at the 13th dimension, when the volume of the 13th dimension hypersphere is 128 pi to the sixth over 135,135 times r to the 13th power. And our one radius ball now has a hypervolume of approximately 0.911. It's gone even below 1, and it shrinks. So pretty wild. There's a lot of strange traits that happen in higher dimensions where sometimes the fourth and fifth dimension maximize certain things and then they go down from there. We're also going to see that in the new episode on the main channel, the next one, of how certain traits about shapes can be more possible in the middle type of dimensions. Obviously, I don't mean middle of all the possible ones, but I mean middle of what we might be talking about, like the third through fifth or third through sixth-ish, sometimes have extra traits that the smaller ones don't have enough room for. The bigger ones have so much room that it's like restrictions or something. So pretty wild. We are going to do some fun things in that episode that's upcoming, because in addition to all the 4 elements and all the dice and all the wild stuff, we also have a little art corner where this one I filmed before I was sick from COVID. So there's an episode that I still have from before that I had a cameraman and a bunch of scenes and stuff. And in the art corner bit, we designed some dice-like shapes to prove things about dice shapes. Someone's saying, are circles even circle? And it's a good question, but circles, yeah. A circle's a circle, yeah. Well, I think it means circular. Are circles even circular? And yes, they are. Now, whether circles exist in nature perfectly is a good question, but my hypothesis is that we can say they do, at least as the limit something approaches as they get more circular. And I do think circularity is something fundamental somewhere in nature in the world, because circularity is just basically like spinning with a central axis. And there's a lot of ways circles pop up. Like if you have a regular polygon, the more sides on a regular polygon, the more circle-like it gets. So, yep, loving the numbers loving all the ways numbers work. Someone mentioned there are so many applications of numbers. A lot of the cool traits you find me talk about with numbers, you may see me in the future demonstrate an entirely different way using visuals, using sound, using shapes. And so, there's a lot of ways you can find these concepts apply to different things. A lot of cool patterns going on. For example, in the square grid that I just dropped, or the square grid counting video I just dropped that I mentioned, in that one, there is a lot of different algebraic patterns that are also geometric patterns at the same time, depending how you view them. And that's when you get a true view of a concept. Well, not true, but that's when you get the deepest view of a concept is the more different ways you can see something work. If you can see something work in one equation, cool. But seeing it work in that equation 5 times isn't going to be better than seeing it work in that equation, seeing it work on a graph, seeing it work in a different equation, seeing it work when we describe logic, seeing it like having different ways of viewing a problem. Favorite regular polygon is a good question. And out of the regular polygons, I got to give it to the triangle, the equilateral triangle. Now, my favorite triangle might actually be the 3, 4, 5 triangle, but the equilateral triangle might tie it in favorite triangle. And out of the regular polygons, it's kind of hard to beat. Now, all of the first ones are really cool because triangle's the simplest and has such cool traits for its simplicity. Like with triangles, not even equilateral, but any triangle has a one in circle that touches each side once, one circumcircle that touches each corner once. It has all these perfect traits that only some quadrilaterals have that are already lost when you're at 4 sides. Regular quadrilaterals, of course, would be a square, and that does have those traits, but you get a lot of cool things with the first few regular polygons. Triangles all over, squares are all over. Pentagons have a lot of cool stuff to do with the golden ratio. Hexagons are secretly a bunch of triangles in disguise. You can make a hexagon out of 6 equilateral triangles, and they have a lot of traits in common. For example, with figurate numbers made of dots, every hexagonal number is one of the triangular numbers as well. Then the 7-sided one is where they start to lose a lot of weird traits. And I'm going to call the 7-sided one cool just for that reason. But after that, it's not as cool to be like the third one that lost the trait. But the trait that the 7-sided one first loses is it's impossible to construct with a straight edge and compass, a regular heptagon, 7-sided. And we're going to go into that in a future video. I've done a short video about it, but I'm going to make a full video about why are certain things impossible to make with a straight edge and compass. Another one that's along those lines is trisecting an arbitrary angle. Not you can't just make the angle and choose it and then trisect it. That would be easy, but out of angle you don't choose, trisecting it. And another is taking a square and making a circle with the same area as it, or vice versa. And another is to take a square and make another square that if they were cubes would have twice the volume. These are all things that turn out to be impossible to construct with straight edge and compass, which I will go into in a video sometime. But one of those that's extra interesting because we can explain multiple reasons we could come to the conclusion of this. So this may even show up in 2 episodes, is that it's impossible to do a regular heptagon, a 7-sided one. It's the first impossible one. Now, it's very interesting which ones are constructible or not. Turns out to relate to a type of prime known as a Fermat prime, among other things. So that's cool. That'll be in a future episode. If you liked my hyper 11s that were these guys called Mersenne primes when we moved to binary land, we're going to get something kind of similar where hollow 11s, the ones that I called the name for numbers that are like 1, a bunch of O's, and then a 1. The hollow 11s show up a lot in a relationship to binary Fermat primes. So we'll see about that. That will probably be a sequel. Probably I'll have to name that episode Hollow 11s because I named one Hyper 11s. So that one was called Hyper 11s and the largest primes ever. So there'll probably be one before too long called Hollow 11s and the constructible polygons or something. Someone said, do you know any mathematical proofs that prove 1 equals 2? Yeah, there are fun ones. I want to make a video involving that too. But here's what I found. With those tricks, it's always obviously some sort of trick because our system of arithmetic does work where if you don't break the rules, 1's not going to equal 2. However, there are ways to break the rules subtly without it being noticed. One of those is, for example, to make an equation where you end up setting a variable b that's equal to an earlier variable a, and you end up doing a divide by a minus b. And that's a divide by zero that can sneak stuff out. And if you're allowed to divide by zero, you can make one equal two, and you can make everything not work. The other thing that sometimes is used to prove stuff like 1 equals 2 is taking functions that are like, I'm in a function, like taking the reciprocal of the square or whatever of something, and then assuming it backtracks, trying to backtrack a function or say that since I proved something within the function, that must be true without the function too. Like if I say function of x equals function of 1 equals function of 2, that doesn't always mean 1 equals 2, you know? So there are ways where people try and secretly backtrack steps you're not allowed to, and ways where people secretly divide by 0. And those are probably the most common in those 1 equals 2 proofs. But there's a lot of fun 1 equals 2 proofs. So I'll probably do an episode about that someday. Someone says they like the 0.999 repeating equals 1. Now that's very different. That's something you prove to show that it is true. That is true in our system of arithmetic. If you want to decide it's different, you can look up other ways of trying to do arithmetic, but then you lose all the other normal rules. So if you want to have all your other normal rules, all the ones you're used to, 0.999 repeating has to equal 1. Otherwise, you can make 1 equal 2. And so with our normal way of using numbers. And so 0.9 repeating equaling 1, there are a lot of good proofs for it, but those are just to prove to people who don't believe it, because it has to be true for things to make sense in our system. And it's also the easiest way to visualize it is 1/3 is point infinite threes, right? So 1/3 times 3 is 1, right? What happens when I multiply point infinite threes by 3? I have point infinite nines. We just said 1/3 times 3 is 1, right? So there's a lot of really simple proofs that it has to be true. Favorite base, like base 2 or base 10, is base 6. But stay tuned for my thoughts on how I am growing fond of some weird ones, like fractional, irrational, negative, some weird bases I'm growing fond of. But I think the most practical for humans is 6. There's actually base 2i, like binary, but with I. We'll see that in an episode for sure. That'll be probably in my episode about negative bases coming soon. I'll have the end of it go into imaginary bases. Someone's saying if infinity 9's repeating equals 1, does that mean whenever infinity equals 0? No. Because I'm not sure why you think those two statements would be correlated necessarily. 1 over infinity is a different thing. Saying we have infinite 9's repeating isn't a number we'd call infinity. It's just something, it's a very dense amount of things in a number, but that's not infinity, just like pi is not infinity. In fact, infinity, you got to be careful if you ever use it as a noun. Infinity isn't often used as a number in math. It's usually used as the amount of natural numbers, or to describe a process continued indefinitely, or sometimes wrongly used to describe something arbitrarily large. And other times infinity can be a number, but then you kind of got to specify which infinity you're talking about if you want to be super clear. I do like to use the infinity symbol in equations and sequences because it's fun and captivating and it can be meaningful. And there are ways it can be accurate. But the infinity symbol really means either this number-like concept that is essentially the size of all natural numbers, or if I'm talking about a larger type of infinity, maybe the size of all real numbers or something, depending on which infinity we're talking about. Or infinity could mean often, like a process going on forever, what the limit approaches. But no, 1 over infinity can't equal 0 in our system either. We cannot use the number infinity in that way. Infinity is a good analogy I heard for it is that if you add any amount of zeros, you're never going to hit 1. You add any amount of 1s, you're never going to hit infinity. So it's just a level up. it's almost like a dimension up, sort of like how spheres are a dimension up from circles. And you could even compare those to the fact that you could say that a sphere almost has like infinite area inside it, because you could, like, if area is flat planes and there's infinite flat planes in it, like inside it a circle sort of has infinite area. And then, so it's sort of a dimension above is infinity. um but nope, you can't divide by it. Although, interestingly, the two most popular combo class videos ever viewed online are me talking about dividing by zero on here and me talking about dividing by zero on TikTok. Those are the two. It's the same video, but it's that for some reason that's the one that got the most amount of million views on both apps. So people like divide by zero errors. There's also a very important divide by zero-ish concept in a book I've been working on for a long time that won't be the first fiction book I put out because it's really important to me, but an insane choose your own adventure-ish fiction maze that I will show you guys at some point that relates to a strange version of my life practically. In that, there's a lot of divide by zeros going on, and there's also just a lot of 0, 1, and infinity being the three most important numbers. But you wouldn't call infinity a number typically. The book, of course, is a little more playful as a fiction book. Now, let's see. Someone's asked my favorite class. Honestly, I've enjoyed learning math outside. Like, I had pretty good teachers, but I've enjoyed more math learning other ways. So my favorite classes were probably like art classes or like things like that, where I had an excuse to have some weird type of like equipment or creative art thing that I didn't normally have access to. Or like I liked here's probably my favorite class. In my elementary school, there was a garden there and a little kitchen by the garden where you would sometimes get a class where you would go to visit the garden, help out like setting up the worm bin, feeding chickens and stuff like that, learn about plants. And sometimes you'd get kitchen period too, and you'd get to cook the garden food among other foods. So those are my favorite, probably those middle school classes in the garden and kitchen. That was fun. There's other fun classes too. The craziest class stories were when I was in 8th grade, which in America here is the last of middle school, and then you go to high school. That was like a different building, a little further across town, not super far, but like downtown, not downtown. And the middle school didn't have a 9th grade math teacher, but I was in a group of people who were in 7th grade who were in 8th grade math there because we like passed some test or something and they put us a year ahead in math, even though I wasn't a year ahead in the other subjects, just math. And so then in 8th grade, I was supposed to be in 9th grade math along with this other group of kids, and they didn't have a teacher. So I think they only did this for my year and maybe one or two other years. They had us get driven for zero period in the morning, like by our parents or whoever, take the bus or whatever, in the morning to zero period at the high school when we were in 8th grade, and then spend first period walking back from the high school. And when we got back to the school, helping out this teacher we were assigned to be this thing called an IWE, an independent work something for. And so that was chaos sometimes. We could just like show up late. We got access to keys to storerooms and stuff when we were working for those teachers. I found out some crazy secrets hiding in that school. Took a massive calculator home. There's a whole calculator heist. So I'm saving the calculator heist story for when I have the calculator. I know I have it somewhere, like in my attic or something. I didn't get rid of that calculator. It's got to be around. I want to know a whole heist for that thing. Oh man, my battery's super low and I didn't get my charger. Let's see, is there even enough battery? Okay, so there would be enough battery to run and get the charger. I don't know if we're going to do another extension. We already did an extension on this stream and it's about to hit 2 hours. So I might just let the stream die right when my battery dies or close it off when I'm at like 2%. But don't worry, I'll be back to stream before long. As you could tell, I'm mostly better from the COVID already. You could probably hear in my voice that I'm not fully better, but luckily it didn't hit me hyper hard. So I'm already past, felt worse the last 2 days than today. Unfortunately, it happened right before Halloween and right before I was going to go on a trip to a friend's cabin for like the first trip to nature since I got 2 surgeries. And so bad timing.
but it's often going to be bad timing that you get sick. So you got to roll with it. On the bright side, it's been cheering me up that this channel's doing insane. And speaking of which, we are now at 45,380, and we have passed the highly composite number. We have passed a number of subscribers that has as many factors as a billion. So, pretty cool. What's cool is how fast this is growing. So people who want to stay tuned for new updates and make sure you're joined in on the community, check out that Reddit, which doesn't have that much going on yet, but it'll get popping more soon, or that Discord link there. And just pop by for more future videos because we will have wilder and crazier and cooler learning as time continues. Although this week will be a little sparser due to me still recovering. So I probably will do more streams and random short videos on this channel, like the grid counting one you can watch when this stream dies. It's sort of like hanging out in a 26-minute class with me learning a longer math lesson in one take. But it's a very focused 26 minutes, unlike my stream here. My streams usually are just for these days, replying to comments and getting carried away with rants and such. But I really appreciate all the comments and an opportunity to think of all this stuff. It is secretly like therapy for me too, to get to talk about all these thoughts. So I'm getting some free therapy out of this as well. So can't complain. And hopefully I'm also doing some good teaching in the process and making some cool digital friends. So, let's see if there's any more comments here. Someone's saying then they're correlated because the 0.9 repeats forever would be correlated to 1 over infinity. Going back to that real brief, that's a different thing. To have an infinite amount of something after a decimal is very different than having an infinite quantity of the size of a number. To call a number infinite means it is larger than any finite number. So it's a different category of number. It's barely a number. You have to stretch the word of number to include it. To call nine point infinite repeating a number is normal because every number has an infinite amount of zeros after it, after the decimal. Apart from some fractions have like an infinite repeating threes. So just like 1/3 isn't an infinitely big number, just the fact that it has infinite decimals after it actually isn't that different than the number 2. That's like 2 point infinite zeros secretly. So every number could be expressed in an infinite way. And in fact, every number has, well, every like number we know, like an integer or the number 1/2 or something, secretly has a clone number that's also it, like 0.9 repeating. Because, like you could say that 0.14 and then infinite nines is the same as 1.5. So all the numbers we know have a little clone number right under them that's identical to them with infinite nines. Well, I mean, I don't know if you could argue that for pi having a clone number or numbers like that, but any integer certainly does, or any fraction certainly does. Or I don't know, at least the fraction that worked there, where 1.5 goes to 1.4999. I'm not sure how you describe if 1/3 has any clones or not. I want to look more into things like that as I go. I like not to say, I mean, I have a guess of how it works, but I like to not say things too confidently in my streams unless I'm pretty sure. Someone wants to know why 0 factorials 1. We'll get into that more in an episode about factorials, but real quickly, the idea behind that, there's a few ways of visualizing that. One, and the main way that I'll say now, because there are many ways we could say why that makes sense, but one way, well, okay, I'll give you 2 ways. One way is that we're asking how many ways can I arrange n items is another version of what n factorial is. So like how many ways can I arrange ABC, like ACB, CAB, CBA, using them each once? How many orders can I put n things in is n factorial. Now, when you have no items, you want to actually consider it that there's an empty set and say that there's one way, which is including nothing. The only way is including nothing, and there's nothing to order. So that's one reason why 0 factorial is 1, is that it's permutations on an empty set, sort of. Another reason logically why it should be is that it's a multiplicative function based on multiplication, And one is the multiplicative identity that makes things not change. And so if you ever have the zeroth term of an additive series that works on addition, it will very often be zero for the zeroth term of an addition based sequence, and very often be one for a multiplication based sequence. Kind of similar to how something to the zeroth power is one. So there are more comments, but like I said, it's going to die really soon. Unfortunately, we're at 5% right now. Someone's asking if I have any sort of disability like autism, because they have it themselves. I don't think I'm very autistic. I probably have it mildly. I think things like that are a spectrum, and I probably have a slight version of it where I get very fixated on projects. I don't have much difficulty socializing or reading emotions or some other things that can be common with autism. So I don't think I have it very strongly. So probably a very shred on that, but it is a spectrum, which is good to be aware of, that it's not an on or off switch. I do have other conditions probably, but it's hard to really know what's going on in your head. Doctors have labeled me as bipolar of the milder form. They have labeled me as possibly having ADHD, definitely having what they call generalized anxiety and panic attacks and stuff. I have. And I've had depression pretty intensely at some points in the past and still have it to a degree. And so I do have a lot of mental things I'm going through, but you guys usually see me very excited because I'm like talking about stuff I love, which is my real self at a lot of times. But I have some really, really hard moments too. Some of those are probably based on ways my brain is built differently. But I don't know how much I agree with those doctor terms because I just have a very different weird brain. I've always been a very weird person. So it's kind of hard to put me on one precise one of those terms. Um, I've been on different medications at different times, so I'll share more about that at some point. Um, but yeah, I don't know. It's hard to define exactly. No need to be too specific about exactly what you have, but it's good to guess which spectrums of things you're further along. I would say I probably have a little bit of bipolar, a little bit of ADHD, maybe a hair of autism, and definitely a health, not healthy, but healthy meaning a large portion of anxiety and depression at times. But I'm working on that. And as I learn more about that, I will help you guys have all that happiness along with me because I do find a lot of beauty in the world despite all of those difficulties. Now, I'm not going to get to all the questions. My battery's literally going to die. Thank you all, everyone, for joining me. I'll catch you again soon. Make sure to watch that grid video on here and rewatch old streams and stuff like that because watching the longer ones really helps the channel right now get like the normal type of watch hours that will get this on the partner program, like the main channel. So that's helpful. But I love you guys all in any case. Hope you're learning fun stuff from me. And thanks for tuning in. I'll see you probably tomorrow.